Hey everybody, it's Jason Fredisco here, and welcome to the first of many of my health and fitness videos. So if anybody has any questions or concerns that they would like answered, or just want any general information on any of the topics under the headlines of health and fitness, whether it's clinical exercise or nutrition, sports performance, strength conditioning, weight loss, anything you guys want to know, just message me, post it, and I'll answer it. So before we begin, I just want to go over a couple things. Various points in this video, you're going to see charts and tidbits from PowerPoints from past educational experiences that I've had. Put up onto the screen so that way for any visual learners out there, you'll be able to see the vitamin D quantities of certain foods and the daily recommended allowances of vitamin D, all taken from the National Institute of Health, because after all, that is the basis of this video, which is supplements, and the biggest topic is going to be on vitamin D to answer the question brought up by Kim. So let us begin. Oh, actually, before we begin, I do want to make a quick shout out because shameless plugs. I just want to congratulate my swimmers from the Long Island Aquatic Center for killing it at the Metropolitan Junior Olympics this weekend, and also to my Long Island Riptide girls softball team for making junior varsity and varsity at all of their respected schools. Now, just so you guys know, these girls are only between the ages of 11 and 14 years old, so 6th to 8th grade, and they are all on junior varsity or varsity. That's huge. So thank you for all your hard work, and I promise to continue making progress with you guys. So now on to the video. Yay! So today's first topic is vitamin D. What is it? Vitamin D is a fat-soluble vitamin. And what is a fat-soluble vitamin? Well, up to 90% of fat-soluble vitamins are absorbed with dietary lipids as part of dietary fat, and that will occur in the intestines, the absorption. So once absorbed, chylomicrons and lipoproteins transport these vitamins to the liver and the body's fatty tissues. So if you don't have adequate dietary lipid intake or adequate amounts of dietary body fat, not dietary body fat, if you don't have adequate amount of body fat in general, you will have a hard time holding onto your fat-soluble vitamins, as well as maybe finding yourself with a fat-soluble vitamin deficiency, whether it's vitamin A, D, etc. So dietary fat is a necessity, along with having some fat in your body. Doesn't have to be a lot, but you do need body fat. So vitamin D is produced naturally from ultraviolet rays from the sunlight when it strikes the skin, and it can trigger vitamin D synthesis. It can also be consumed through adequate nutrition and or supplementation if need be. There are two functional forms of vitamin D that are synthesized in the body through very specific biochemical processes. If you can't tell, yes, I am reading from a script, and it's only because of one reason, because I tend to go onto tangents, and I don't want that to happen in this video. So for the purpose of everybody's time and this video, if you want to know any of the crazy in-depth information about the biochemistry or the physiology behind a lot of this stuff, privately message me, and I will gladly go on for days, like everybody knows I can, about all this stuff. So now let's get back to the script so it keeps me on point. Okay, so the first of those two aforementioned functional forms is synthesized in the liver to convert vitamin D to what's called 25-hydroxy vitamin D. To the public, we know that as calcidiol. The second occurs primarily in the kidneys and forms the physiologically active 1,25-dihydroxy vitamin D, or what we know it as calcitriol. Vitamin D, its main functions are to promote calcium absorption in the gut and allow for the maintenance of adequate serum calcium and phosphate concentration. That's also something that a lot of people don't really know too much about, is that you really need a proper balance of calcium and phosphate in your body to enable proper normal bone mineralization. It's also to prevent several things. One is a neurophysiological I don't want to say disease, but a disorder that can definitely happen called hypocalcemic tetany. And just so we don't have to go crazy into it, most of you know what tetanus is, and it's basically the inability to come out of a contraction. So if the muscle contracts, so apologize for that noise, that's my computer telling me to update it. The muscle contracts and it's not able to come out of that contraction, and it has to do with calcium balance and neurophysiology. So let's not get too much into that. So dietary supplements. You can either acquire them in vitamin D fortified foods or in just straight supplement forms. Either way, at least to my knowledge, I've really only read about and kept up with 2 forms. I really don't think there has been any new forms used as of lately in the literature, but it's vitamin D2 and D3. Vitamin D2 we know as ergocalciferol, and D3 as cholecalciferol. There's barely any difference chemically with them. It has to do with their side chain structures, and for the most part, the way that they're used in metabolism and actions almost the same, so we don't have to go too crazy with that. However, vitamin D2, it is manufactured by the UV irradiation of ergosterol found in yeast, and vitamin D3 is manufactured by the irradiation of 7-dehydrocholesterol, which we will talk about a little later on when it comes to exposure to the sun. But that is created from the irradiation of 7-dehydrocholesterol from lanolin and the chemical conversion of cholesterol. Both of these forms have been traditionally used to cure rickets or the malformation of bones that used to be a huge problem with children, not so much in this country because we are fortunate enough to have adequate nutrition in our lives. But both of these supplements, along with nutrition and sun exposure, all have led to the ability to increase serum calcidiol levels. So either way is good. You just need to maintain it. Yeah, how is that for the most scientific answer you ever heard? Just maintain it. Anyway, most people meet at least some of their vitamin D needs through exposure to the sunlight. Ultraviolet B radiation is the form that we are most familiar with that occurs through skin exposure. So when that penetrates uncovered skin, it stimulates the conversion of 7-dehydrocholesterol, which you just heard me say before, to pre-vitamin D3, and then it's converted to vitamin D3. Various things can actually alter how much sun radiation we can get. That can be season, time of day, length of day, cloud cover, smog. Another important thing, skin melanin content, because that has to do with your skin pigment. So various skin tones really can change how much sun exposure you would need, like the length of time you actually need to be exposed to the sun for proper vitamin D3 formation. People with darker skin tend not to burn in the sun, where somebody as pale as a ghost like me burns easily in the sun. So pigmentation has a lot to do with your vitamin D3 synthesis when exposed to the sun. Anyway, this is why I was supposed to stick to the script, but I keep going off. Yeah, so season, time of day, temperature, all those things can vary because I don't know about you, but when it was below freezing this winter, I sure as hell did not get enough sunlight exposure because I was wrapped up in a cocoon. So, yeah. But either way, it's not like you need to be out there sunbathing every single day. It has been shown that as little as 5 to 30 minutes worth of sun exposure, and that can literally just be done between the hours of 10 a.m. and 3 p.m. because that's when the sun's, the angle of light is at its optimum position for radiation exposure to the sun. But that can be done as little as the 5 to 30 minutes a day, twice a week. Face, arms, legs, back. As long as they're exposed, they don't have too much sunscreen on them, that can lead to sufficient vitamin D synthesis. I really hate to say this, but yes, tanning beds can provide vitamin D. I said it, I don't really promote it because of the fact that most people go in there and abuse it and come out looking like lobsters, or their skin just looks like a pumpkin. and then they get skin cancer. But tanning beds that emit 2 to 6% of ultraviolet B radiation can be effective. Just make sure that you do not allow yourself to burn like a lobster. So that's the basic rundown on vitamin D3. I apologize for any of the stuttering or anything like that. If anybody would like to know more in depth about how vitamin D3 plays into metabolism, I can definitely get into that more. I'd like to make another video about that because there's a lot of news happening in like the health and fitness magazines, not peer-reviewed literature promoting it, but straight out magazines, and I've seen it on TV where people are saying, oh, vitamin D helps with weight loss and body fat percentage, things like that. It's not like it is. It's not like something like a weight loss supplement or anything like that. It just has to do with the role of vitamin D with metabolism, and if somebody has a deficiency, well, then their metabolism is going to be altered. But in the normal healthy population, there needs to be a lot more research done on that. So if you want any more information, let me know. Okay, welcome back, and now I'm standing up because it's a new topic. Let's get a change of angle. So right now I'm going to go into a supplement that I feel is really important to talk about because the majority of all the athletes I work with and all my friends who want to get big and strong or whatnot, they're all on creatine. So let's clear up what it is, what it does, some of the myths, things like that. I'll make it quick since I spent like a million years talking about vitamin D when this is probably the supplement that everybody's tuning in to really talk about. So let's get to it. Creatine. Creatine is chemically known as a non-protein nitrogen. It literally means that it is a compound that contains nitrogen, but it's not really considered a protein per se. Leave it at that. You can argue whether it's amino acid or not any other day. So it's synthesized in the liver and pancreas from 3 amino acids, which are arginine, glycine, and methionine. Approximately 95% of your body's creatine pool is stored in skeletal muscle. Additionally, small amounts of creatine are also found in your brain and in males in the testes. Other than that, the majority is going to be in the muscle. The total creatine pool in the skeletal muscle averages about 120 grams for an average 70-gram individual. When I say average, I mean a healthy, normal population. There are some people that have been found to have a capacity as high as 160 grams of creatine under certain conditions. We don't need to go crazy into that. But just know that 120 to 160 grams is about the average of what somebody's normal creatine pool is. When creatine is broken down and used in the body, it's usually about 1 to 2% of that entire creatine pool per day. So that's really small. It's only about 1 to 2 grams if you want to put it in something that people, like a tangible amount, because normally when you consume creatine supplements, it's in grams of creatine monohydrate. So 1 to 2 grams per day is the amount of creatine that's really used up. Yes, can it be higher or lower depending on your activity level? I guess. But we're talking general terms here. When it is used, it is converted into creatinine, and that is then excreted in the urine. Creatine stores can then be replenished by consuming creatine in your diet from meats, whether it's red meat, it could be poultry, any meat in general, and fish. They all vary in their amounts, but meat in general. Vegetarians and vegans, you guys might have a more difficult time dealing with it, more so vegans than anything else because you don't eat meat at all, or eggs or anything like that. At least a vegetarian consumes eggs, for the most part. So yes, the amino acids glycine, arginine, and methionine. So whether you're supplementing with those 3 amino acids or creatine in general, or eating meat, you're getting creatine. Let's go down into the biochemistry and the metabolism portion of it, because this is the real reason why I feel that anybody who wants to take creatine should take it for. It has to do with your ATP production. Now, ATP is the body's it's the form of energy that your body uses to do cellular work, whether it's muscle contractions, digestion, anything. It's ATP. So everybody always says, oh yeah, the mitochondria is the powerhouse of the cell, it produces ATP. Well, yes, that's one way that you can, but ATP. Stick to the script, right? Yes. So, ATP, when it's used for energy, it's then broken down into a lower energy phosphate. So it goes from ATP, which is adenosine triphosphate, to then adenosine diphosphate, and it could be broken down even further into adenosine monophosphate. What does that mean? It means that you need to convert ADP or AMP back to ATP in order to be used for efficient energy. The fastest way that can happen in the muscle, let's just strictly talk muscle here, is through your ATP-PC system, which is ATP phosphocreatine system or creatine phosphate, however you want to call it. We can use those terms interchangeably here. So what happens is the phosphate that's contained in phosphocreatine is detached and forms with ADP to then convert it back to adenosine triphosphate. So it's a quick turnover for ATP to be resynthesized. That is what's used for the most high intensity portion of any bout of exercise or athletic event. So that's usually between like the first 3 to 5 seconds of the bout or event. A lot of repetition, as you can see, in exercise physiology and nutrition for that matter. So say somebody's about to sprint as hard as they can. Well, the first 3 to 5 seconds is going to really be hitting hard the ATP-PC system. Then, in conjunction with that, you're going to start seeing the shift into anaerobic glycolysis, which is where your lactic acid production is going to be significant. So what you want to try to have is optimal ATP storage in your muscle, so that way you don't even have to go to your PC system. But you're genetically handed the amount of ATP that you're able to store in your muscles. So when that starts to decrease, ATPC comes in, anaerobic glycolysis, aerobic glycolysis, fat beta oxidation, all those energy systems can all be happening at once or in tiers as far as the percentage of their contribution to the energy pool. Everybody's head is probably about to spin. They probably don't want to kill me for going too far into it. So to summarize all that, creatine allows ATP resynthesis to happen very quickly and allows you to sustain high intensity exercise for slightly longer bouts. That's it. So when people say, oh yeah, I'm taking creatine to get huge, I don't know why. When they're saying I'm taking creatine for hydration, I don't know why. If you're looking at it as strictly as an athletic standpoint, look at it as a way to increase your anaerobic power. Now, to go back, piggyback onto that with some of those myths, yes, can it increase muscle hydration? Absolutely. But it's because of osmosis. It's simple osmosis. If I ingest creatine and now my muscle cells have more creatine in there, well, now more fluid or water has to be retained in that muscle cell to dilute that concentration of creatine. That's where the water retention comes into. That water retention can easily be mistaken for an increase in lean body mass, especially during certain body composition tests where water can be included in lean body mass. So it'll overpredict your lean body mass percentage and underpredict your body fat percentage. So you have to kind of weigh the pros and cons with that. However, in the literature, it has been shown that creatine can increase lean body mass, actual cross-sectional area of muscle. And that has been shown through MRI, actual biopsy of muscle tissue. All right, so a couple of theories exist on why the cross-sectional area of muscle can increase, or let's just call it muscle hypertrophy because that's what it is. So the increase of having creatine in your body will allow you to sustain high-intensity exercise for longer. So your anaerobic power has increased and your anaerobic endurance has increased. So that might translate to a greater training stimulus due to that higher volume of higher intensity work. So that alone is a hypothesis of why the muscle is able to grow significantly bigger. Another theory could be the fact that certain genetic pathways can be increased by consuming creatine. One being the AKT-mTOR pathway, increases in mRNA, DNA, literal increases in them have been seen with creatine. Increases in HGF, IGF-1, other anabolic hormones have seemed to be increased with the consumption of creatine. So they're not sure if it just, has a way of stimulating all these genetic limiting factors or not. So yeah, it can get very wordy, but there's still a lot more research they want to see with that, which is why a lot of athletic committees have wanted to ban the supplement. But then you can argue, okay, well, if a marathon runner is going to carbohydrate load before a marathon, so that way he increases his ability for glycolysis, an anaerobic athlete wants to creatine load so that way they can increase ATPC turnover, so that way they can increase their anaerobic endurance. So that's why it really hasn't been banned from anything, and plus there hasn't been shown to be any significant clinical side effects from taking it. So do I take it? No. Do I recommend taking it? No. Why? Because I feel you can get everything you need from nutrition. If all else fails, yes, then we go to a supplement. But for that matter, do I really think there's anything wrong with taking it? No, as long as it's just straight creatine monohydrate, which is the most effective form of creatine supplementation. There have been other brands and other chemical forms of it, but creatine monohydrate has been the most successful and has shown the least negative impacts. So if you buy something like No Explode or Stacked or any of these things, whether it's pre-workout or post-workout recovery, when they have all this other stuff in it, you don't know what it is that's actually working for you. And the same thing goes for creatine when it comes to this one major thing, and this is what I'm going to leave you on. If I'm taking a supplement, and that supplement is the reason of why I'm seeing increases in any of my health and fitness gains, what happens when you stop taking it? You lose it. So the notion becomes, well, you're just going to have to be on it forever if you want to maintain that. So that's why I feel like you should get to your maximum capabilities, so the highest level of human performance that you could possibly get to, before you even consider that as an option, any supplementation. So that's why it's important, and no, this is not a shameless plug, but working with an exercise physiologist or somebody who really has high understandings of human performance, not just a certified personal trainer or these fitness gurus or anything like that. I mean somebody who has real sound knowledge and experience with physiological testing, metabolic testing, all those things. That's what's necessary. Without finding out baseline data, you cannot have any sort of quantifiable method to training. So you always need to be tested. Everything has to be catered to your specific physiological needs, and that's how you get somebody to their top in their top human performance shape. So I'm pretty sure what I just said there didn't make any sense, but that's fine. You all got what I mean. So let's end it on a good note. Stay tuned. I hope you enjoyed this half an hour rant of mine. I promise the next videos will be a lot shorter, so that way they'll just get straight to the point and answer questions, but I really wanted the first one to be kind of wordy and in-depth. So hope you all enjoyed, and that's my dog barking, so I gotta go take him for a walk. See you later, guys.